Hello and welcome to hopefully my last video on stoichiometry. This is a video about gram to gram conversions, which on the surface seems complicated, but it's not. It's just combining conversions you already know how to do and just doing them in a certain order. So this is our little map that we're going to follow in order to do this kind of conversion. But let's look at the question first. The question says, given 68 grams of H2, how many grams of O2 are needed to fully react? So we're going to need to use our mole ratio, but we don't have moles. We were given grams, and so we're going to need to do a gram to mole conversion in order to use our mole ratio. All of that to say, your first step is to do a QMT chart for each of your compounds or substances in your question. So our first substance was H2, and so I did a QMT chart for H2, quantity of 2, mass of 1, total of 2 grams per mole. And same thing for O2, quantity of 2, mass of 16, 32 grams per mole for O2. The next thing I like to do is to find the things in my question and label them. So 68 grams of H2, that's my given, and I'm going to underline that in pink, and I'm calling that A. And that's just going to help me keep track of what I'm doing. The other one, what they ask me for, is grams of O2. So I'm going to do that in blue, and I'm labeling it B. Okay, step 2, oh, I called it step 1, but I already called this step 1. It's fine. Step 1.5 is to turn grams of A into moles of A. In order to use my mole ratio to figure out the ratio between H2 and O2, I need to have moles. I can't use mole ratio without moles. So I'm going to need to turn my 68 grams of H2 into moles. So I'm not doing anything yet with O2. I'm only dealing with H2 right now. So I have 68 grams of H2, and I need to do a gram to mole conversion. And if you forgot how to do gram to mole conversion, I would look at your graphic organizer. I would go watch my other video on that. But you need to have, if you have grams here, then you need to have grams here. And we're going to indicate, since we're going to end up doing a mole ratio, we're going to end up changing our substance. I'm indicating what kind of substance. So grams of H2, grams of H2. If you're using molar mass, then that means the other side is going to be mole. My molar mass for H2, I calculated, was 2 grams. So that's going to go here. And then my other side, anytime I'm using molar mass, my other side is always 1 mole. 68 times 1 divided by 2, and I end up with my final answer of 34 grams of H2 canceled out, and so my only leftover unit is going to be mole of H2. 34 mole H2. That's not my final answer. The question did not ask me for moles of H2. The question asked me for grams of O2. So my next step is going to turn these moles of H2 into moles of O2. And that happens with a mole to mole conversion. I'm still using pink because this is still H2. It's just in a different unit. It's no longer grams, now it's moles. So I'm going to put my given right here, which is what we calculated. 34 mole H2. So whatever you calculate here, that's your new given. This is a mole to mole conversion. So if you forgot how to do a mole to mole conversion, look at your graphic organizer, watch my video on mole to mole conversions. But we know from that if this is mole H2, diagonal has to be mole H2. And then your top unit needs to be whatever you're trying to turn it into, which we're trying to turn this into moles of B, which we already called O2. So we need that to be mole of O2. And so that means if we're trying to turn it into mole O2 needs to be our unit up top. And with a mole to mole conversion, you have all moles here, nothing to do with grams. You don't need to look at any QMT charts at all. You only need to look at the coefficients in front of your compounds in your chemical equation. So for H2, I have mole H2 here. My number in front of H2 is 2. So that's what I'm going to write. And then I have O2, mole O2. I go over here to O2. There's nothing there. If there's nothing there, we assume it's 1. So now we say 34 times 1 divided by 2, and we end up getting 17 because mole H2 canceled out. The reason I've switched to blue now is because I have officially switched over to O2. I am in moles of O2. I no longer have H2. However, I'm not done because the question didn't ask me for moles of O2. The question said how many grams of O2. So I can take this number and turn that into grams. So this is my last step. This becomes my new given. 17 mole O2. And I'm going to turn that into grams of O2. That's going to be my final answer. So now we're going to do a mole to gram conversion, which happens similar to a gram to mole conversion. If this is mole, then this is mole. And I'm going to indicate that it's O2. And that means my grams can go on top. I need my molar mass of O2. So when I go over here to my QMT chart, my molar mass of O2 was 32 grams. So that goes here. And anytime you're using molar mass, the other side is 1 mole because it's 32 grams per 1 mole. That is 17 times 32 divided by 1. Mole O2 is going to end up canceling out, and grams O2 is your only leftover unit. And so your final answer is going to end up being, I don't remember. Oh, I do remember. It's 544 grams. Took me a second. So that is your final answer. After all this work, you figured out that with 68 grams of this, you're going to need 544 grams of this to fully react. Very involved, but it's conversions you already know how to do. You just have to remember the order. Grams to moles, moles to moles, moles to grams, and then that's it. All right, let me know if you have any questions, and I will see you in class. Goodbye.